Okay, so this question about chi-squared and table of contingency, and we are looking for running the chi-squared test, right? So let's see, here we have certain data we want to figure out. The data are shown in the table at the level, so this is my claim, at the level of alpha is going to be 0.01. Is there a relationship between the type of automobile owned and the gender of individual? So we are looking for a relationship. Ours relationship means dependency, dependent or not dependent. All right, so we are running here. There is a relationship means they are dependent. There is no relationship means not dependent, just mean independent. So ours, the 80, they are independent, ours. All right, so this is by default. The 80 are independent. And obviously this is not the claim, because the claim they are saying there is a relationship. There is a relationship means dependent. So this is not the claim. And H1 is they are dependent on gender. So the type of automobile, cars, and they are dependent on the gender. And this would be my claim. All right, so let's go to next part. We are looking for the critical value of chi-squared. All right, so remember what you need here. You need two things: degree of freedom and the alpha. Now suppose you don't remember the formula for degree of freedom, although I'm going to do it later on, but I'm going to skip steps and I'm going to do it. So degree of freedom, it will be given by the calculator. So now if I want to calculate the chi-squared test, which I assume this will be the next question, this is the critical, it's not the same. All right, so what I need to do, how to do this? So the first thing to do is to go to matrices. So you're going to go to second and matrix here, and then you're going to go to edit. All right, and enter. So I have a table here from previous work. I don't really need to clear it because once I change the dimension, it will be overwritten. So I can see here I have two rows, men and women. So that's it will be 2. I need to make sure that's 2 in the row line. And then I have 4 categories: luxury, large, middle size, and small. So that's I'm going to put 4 here. Once I do that, I enter, the table will change. All right, so it happened to be the same dimension as the previous one, but the table will change. Make sure you enter the data, all right, whatever you see here, correctly. So the first entry is 10, and enter. So you see here the highlighted one will be the next one on the right. So we are entering the data in a row fashion way. So the first row and then the second row. So I'm going to go with 15. I think you get the idea. 20. And then 22. So as soon as I finish the line, the calculator will restart the other line. All right. I'm going to put 40 here. 35. 30, 28. Okay, great. So I'm done with the matrix. So now I'm gonna go and run the test. The test is under statistics. So you go to run the test here, and what you are looking for, you're looking for chi-squared of independence. All right, there is 2 chi-squared, where it's one goodness of fit, and there is a chi-squared test. You are using for this one chi-squared test every time you have a contingency table chi-squared test. So the observed value is by default is A. That's where we put our data. It's good. And then the expected value, this calculated will be created by the calculator, so don't worry about it. And then you're gonna go calculate and enter. All right, so what you get chi-squared here is 7.789. You get the probability going to be this, and you get degree of freedom 3. So I'm gonna take note of the chi-squared because I will need it later on. I think that's the degree of freedom, so you can get it by the calculator. All right, so now let me explain how do you get the degree of freedom by the formula. All right, so the degree of freedom, we have a formula here, is always equal to number of rows number of rows minus 1 times number of columns minus 1. So the only thing you can identify how many rows you have. So R is going to be 2 here. And how many columns you have? Columns are going to be equals to 4. So then you can do it right away, which is 2 minus 1 times 4 minus 1, and this is going to be 3. All right, so now we define the 3. We have the 3 as degree of freedom. What we need as well, we need the alpha, which is, according to text, is 0.01. So the alpha is 0.01. And now you have two choices, either use the table or use the calculator. So let me show you how to go about this in the calculator. Before going for any further, I'm going to copy chi-squared test. So this is chi-squared test. I don't want to go back to this, so it can be 7.7881. So at least I know it. Okay, so what I'm looking for. All right, so let me try to, I am looking for chi-squared critical. All right, so chi-squared critical is different, right? Chi-squared critical. So how can I get it? Again, is you can get it from second and vars, which is distributions. And then you're gonna go to chi-squared. Oh, I don't have a chi-squared inverse. All right. So for chi-squared, the only thing you can do, I mean, the easiest one, you can, right, the easiest one to do it is to use the table. So in that case, you have to go and use your table. And the table, again, that you're going to be using, you want to use the chi-squared table, chi-squared here, which is table G, right? So you're going to go in table G. This is the chi-squared table. So we were saying degree of freedom is 3, so I am here. And I am looking for alpha 0.01. So 0.01, I think you have to go further, and this is it. All right. So this is 0.01, which is 11.345. So that's how you get it, right? So 11.345. So what the meaning of this? It's simple. The meaning is I'm having my chi-squared. It's gonna look like this. This is a chi-squared distribution, supposedly. Right? There are many, but this is the most common value. And here I have, if I'm having the tail here equals to 0.01 with a degree of freedom equals to 3, then the chi-squared critical, the cutoff, is going to be 11.345. And this is going to be my rejection zone. So if this is going to be reject 80. All right. Now, because I did already calculation of chi-squared test, which is this one, so I can tell the chi-squared test is before that, right? So it's 7.788, right? So definitely I'm not rejecting. This is do not reject zone. Do not reject 80. And that's basically explain the question what you are doing, right? So let's follow up with the questions here. So if I'm looking for the critical value, we say is 11.345. Double check. Good. Now, if I go to next one, so next one is chi-squared test and 3 decimal places. So that's what we did earlier in the first step. So this is 7.788. 3 decimal places. Next question. Okay, so on the third part, we entered already chi-square test, which is 7.788. Now, the following question is asking whether you accept or reject the null hypothesis, and you can see it clearly here. The chi-square test is right here within the do not reject zone, so is not within the rejection zone, which is after 11.345. So here do not reject. All right, did not reject. And if I did not reject, that means I did not have enough evidence. And the claim is H1. So you can see the claim here is H1. So if I am not definitely, if I choose H0, definitely I'm not supporting the claim, right? So there is not enough evidence to support the claim. There is not enough evidence to support the claim. And that's all for this question, guys.